Hi students, welcome to Methodology classes. Today I have got the 2026 CBSE class 12th maths paper, and this is set 2. Question paper code is 652/2 and its series is PQSR2. So let's quickly go through the MCQs of this paper. So the first question is a simple question based on the integration, and it utilizes basic concepts of the trigonometry. So it is integral of dx over 1 plus cos x. So we know we can write this as integral of dx over 1 plus cos x is 2 cos square x by 2. So which can be, we can take 1 by 2 outside. Integral of 1 by cos square x by 2 is sec square x by 2 and dx, and this can be written as 1 by 2 integral of sec square x by 2. So integral of sec square x by 2 will be 10x by 2 and 1 by 2. So 1 divided by 1 by 2, so it will be 2 here. So 2 will cancel out, and it's an indefinite integral, so we have to add the constant of integration. So it will be 10x by 2 plus c. Option D will be the answer of the first question. Now moving to the second question. For the function f of x is equal to x plus 1 by x, and given it is x is not equal to 0, because if x will be 0, then 1 by x will not be defined, so this function will not be defined. So for the function fx is equal to x plus 1 by x, there are 4 options given, and we have to tell which one of this is true. Local maximum, local minimum. So basically we have to find out the maximum or minimum of this function and tell which option is correct. So for the finding out maximum and minimum, we know we have to find out the first derivative, that is f prime of x. So if I derive this function, so it will be 1 minus 1 by x square using the definition of the differentiation. And for the maximum or minimum, this first derivative should be equal to 0. So from here we get that x should be equal to plus minus 1 for this function to be 0. And to find out, so these are the possible points where this function can be maximum or minimum. So to find out at which point the function is maximum or minimum, we have to find out the second derivative. So second derivative will be, it will be equal to 2 by x cube. So the derivative of 1 will become 0 and derivative of negative 1 by x square will become 2 by x cube. So second derivative is 2 by x cube, and we know if second derivative is negative, then the function has its local maximum value, and if second derivative is positive, then it will be having local minimum value. So at x is equal to 1, if we see, it will be 2 by 1, so it will be positive. So we can see at x is equal to 1, f double prime of x is greater than 0. So the function will have its local minimum value at x is equal to 1, and a local minimum value will be, if I substitute x is equal to 1 in this function, I will be getting 2. So local minimum value is 2, but it is saying local minimum value is minus 2, so this is not possible. Now if we see, if we check at x is equal to minus 1, so at x is equal to minus 1, f double prime of x will be less than 0, 2 by x cube will become less than 0. So the function will have its local maximum value, and if I substitute x is equal to minus 1 in this function, so I will be getting minus 2. So local maximum value is minus 2. So the option C is correct for this. Moving to the question number 3. Which of the following expressions will give the area of region bounded by the curve y is equal to x square and the line y is equal to 60? So if we draw the curve of this function, so y is equal to x square is this function, and y is equal to 16. Let's assume this is x, this is y, and this is 16. So this is y is equal to 16 and this curve is y is equal to x square. So we have to find out the area of the region bounded by the curve y is equal to x square and the line y is equal to 16. We have to find out this area So we have to find out this area bounded by the red part. So if we see, this region is double, this area is double of the area, this area, the green one, setted by the green one, and this green part is bounded between the curve y is equal to x square and y axis, and y is ranging from 0 to 16 on this. So we can area of this green part, we can write 0 to 16 x dy, and from here y is equal to x square, x will be equal to root y plus minus root y. So minus root y will be for the left part. So from here we can double it because both the areas will be equal. So it will be twice of 0 to 16 x is equal to root y dy. So option D is our answer. Moving to the question number 4, the general solution of the differential equation x dy minus y dx is equal to 0 is. So we have to find out the general solution of this function. So general solution will consist of constant, general constant. So x dy minus y dx is equal to 0. So if I multiply it by negative sign, so I can get y dx minus x dy is equal to 0, and we can divide it by y square. So if we analyze it, so if we see, this is the differentiation of x by y. So y dx minus x dy over y square is equal to 0. So if I integrate it, I will be getting x by y is equal to k. So x is equal to ky. Option C will be our answer. The integrating factor, moving to the question number 5, the integrating factor of the differential equation 2x dy by dx minus y is equal to 3 is. So if I just simplify it a little bit, so we can divide it by 2x. So we will be getting dy by dx minus y by 2x minus y by 2x is equal to 3 by 2x. So this is of the form dy by dx plus py is equal to q, where p and q are the functions of x or constants. So from here, if I compare, in place of p, I am having minus 1 by 2x, and if this is the equation, then the integrating factor is given by e to the power integral of p dx. So in place of p, we have minus 1 by 2 1 by x dx. So from here, I will be getting e raised to power minus 1 by 2 logarithm of x. So from here we will be getting x to the power minus 1 by 2. So x to the power minus 1 by 2 is 1 by root x. So option B will be our answer. Moving to the question number 6. If modulus of a is equal to 5 and minus 2 is less than is equal to lambda is less than is equal to 1, then the sum of the greatest and the smallest value of modulus of lambda a. So modulus of lambda a will be mod of lambda plus times mod of vector a. So that will be, for the maximum we can substitute minus 2 because its magnitude will be more than the magnitude of 1. So maximum will be 2 times mod of a, that is 5. So 2 times 5 is 10. And we have to find out the sum of the greatest and the smallest. So smallest possible value of mod of lambda a will be when lambda will be equal to 0. When lambda will be equal to 0, then it will be having the smallest possible value, that will be 0. So its sum will be 10. So option C will be our answer. Vector of, moving to the question number 7, vector of magnitude 3 making equal angles with x and y axis and perpendicular to z axis. So the vector is perpendicular to z axis, it means its direction cosine will be 0. So it will not be having k. So these are not the possibilities, k unit vector, and it is having a magnitude of 3. If we find out its magnitude, so it will be 3, but both the coefficients of I and j are not equal. So they are making different angles with x and y axis. So option C will be our answer. Because in this case, the coefficients of I and j are equal, it means they are making the same angle with x and y axis. Question number 8, direction cosines of the line x is equal to y is equal to 1 minus z r. So we have to find out the direction cosines of this line. So this function can be written as x by 1 is equal to y by 1 is equal to z minus 1 by minus 1. And these are the direction ratios of this line, but we have to find out the direction cosines. So direction cosines, we have to divide each of this by square root of 1 square plus 1 square plus minus 1 square, that is square root of 3. So we will be getting 1 by root 3, 1 by root 3 and minus 1 by root 3. So option B will be our answer. Question number 9. In a linear programming problem, the linear function which has to be maximized or minimized is called. So we know in a linear programming problem, the linear function which has to be maximized or minimized is called an objective function. Question number 10 is also based on the same linear programming problem. So for the feasible reason shown below, the non-trivial constraints of the linear programming problem are. So the shaded part is this. So the non-trivial constraints we can see. So we have to find out the equations of these lines. So we can see, let me choose a color, and this blue line, the shaded part is above this blue line, and if we use the intercept form of the line, so this equation of this line is x by 5 plus y by 5 is equal to 1. So we will be getting x plus y is equal to 5. X plus y is equal to 5. So we can see the feasible region is above this line. So if I want to check any part which is above this line, suppose 6, 1 is above this line, we can see 6, 1 is above this line. So if I substitute 6, 1, so 6 plus 1, 7, we will be getting 7. So we can see that any point in this feasible region is greater than 5. Their sum is, the sum of the coordinates x and y is greater than 5. It means this the area above this line will be under x plus y is greater than is equal to 5. And if we want to find out the equation of the second line, so it is cutting x-axis at 9, so it will be x by 9 plus y-axis at 3, so y by 3 is equal to 1. If we multiply by 9, so we will be getting x plus 3y is equal to 9. But the feasible region is below this line, so this point we can take 5, 1, 5, 1. So if we take 5, 1, so 5 plus 1, 8, 8 is 9, so 8 is less than 9, so we can see that the feasible region is below this line, so that will be possible when x plus 3y is less than is equal to 9. So option C will be our answer. Moving to the question number 11. For two events A and B such that P of A, probability of A is not equal to 0 and probability of B is not equal to 1, then probability of A naught over B naught. So we know probability of A naught over B naught. We can write this as probability of A naught intersection B naught over probability of B naught, and which can be written as probability of A union B complement over probability of B naught. And probability of A union B complement, we can write it as 1 minus probability of A union B over probability of B naught. So option D will be our answer. Now question number 12, it is an easy question. A relation R on set A is equal to 1, 2, 3 defined by this is reflexive or reflexive transitive. We have to tell which of the option is correct. So R is surely not reflexive because it is not containing all the elements which are related to itself, that is 1, 1, 2, 2 or 3, 3. So it's not reflexive, so all these two options went away. Now let's check for symmetric. So 1, 2, 2, 1. So 1, 2, when we call it relation symmetric, if AB belongs to the R, then BA should also belong. So 1, 2 belongs, then 2, 1 also belongs. So it is symmetric. So symmetric, this function is symmetric. Let me check whether it is transitive or not. So when we say function is transitive, if A is related to B and B is related to C, then A should be related to C. So here 1 is related to 2 and 2 is related to 1, but 1 is not related to 1. So it is not transitive. So the answer will be option D only, symmetric only. Now question number 13 is based on matrices. So if A and B are square matrices of the same order, then which of the following statements is or always true? So A plus B into A minus B is equal to A square minus B square. So logically it seems correct because in real numbers this relation is valid. But in matrices, if we check, so if I open the bracket, so I will be multiplying A dot A minus A dot B plus B dot A and minus B dot B. Right. So it's not always true that A dot B is equal to B dot A. And it is possible only when the two matrices commute with each other. But all the matrices do not commute. So this can be true, but this is not always true, and this is also not always true. Option 3 is correct. It is always true if we open the bracket. And AB is equal to 0, product of two matrices 0. This implies A is equal to 0 or B is equal to 0. This is also not necessary. It is possible if both the matrices are not 0 and their product is 0. So only option 3 is correct. Question number 14. If A is equal to, it's a 3 cross 3 matrix, is a symmetric matrix, then the value of 3A plus B plus C is asked. So symmetric matrices means its rows and columns should be same. So A should be equal to A transpose. So when we have to make, then the matrix should be symmetric, or it should look same along the diagonal. So for that, A should be equal to minus 1 and B should be equal to 0 and C should be equal to 5. Because when I will be changing rows to the columns, then A will come in place of minus 1. So it should look same. So A should be equal to minus 1 and B will come in place of 0. So B should be equal to 0 and C will come in place of 5. So C should be equal to 5 and we have to find out the value of 3A plus B plus C. So 3A is minus 3, B is 0, so it doesn't matter, and C is 5, so minus 3 plus 5 is 2. So option A will be our answer. And we have to be very cautious. We found out the value of A, B and C, and if we find out 3A minus 3 plus B plus C, A plus B plus C, then we will be getting answer 4, and that is also option C. So we have to be cautious that what the question is asking. Now question number 15. If A is equal to this and A plus A transpose is equal to identity, then the value of x belonging to minus pi by 2 to pi by 2 is. So A is given, and if I find out A transpose, so I have to change the rows to columns. So half cos x minus sin x, and this will be sin x, and half cos x. So this is A transpose. So if I add A plus A transpose, so half cos x plus half cos x, it will be cos x. And if it has to be identity matrix, then it will be equal to 1. So cos x is equal to 1 means x is equal to 0. Minus sin x plus sin x will become 0. Sin x plus minus sin x will become 0. And again half cos x plus half cos x will be cos x. And we need 1, so x should be 0. So option C will be our answer. Now question number 16 is a direct question based on the properties of the matrices. So we know 3A inverse will be equal to 1 by 3A inverse. So option C will be your answer. Now if question number 17, or 3 cross 3 matrix is determinant is given and its value is given to be minus 86, then we have to find out the sum of all possible values of A, sum of all possible values of A. So if we open the determinant along the first row, so it will be minus 1, and leaving the first row and the first column, we will be getting a matrix 2 cross 2 matrix, so that will be 2A square and it will be plus 4, and taking the second element 2, so we will be leaving the second column and the first row, so leaving that we will be getting minus 4A plus 5 and it will be minus 8. This would be equal to minus 86. So minus 2A square minus 4 and that will be equal to minus 8A, and this will be equal to minus 40 is equal to minus 86. So minus 2A square minus 8A minus 44 and minus 86 will come on this side, so plus 86. So minus 44 plus 86, it will be 42 is equal to 0. If we divide by negative 2, so we will be getting A square plus 4A minus 21 is equal to 0, and on factorizing we can get A plus 7, A minus 3 is equal to 0. So A is equal to negative 7 and A is equal to 3. So there are two possible values of A, that is minus 7 and 3, and their sum will be minus 7 plus 3 is minus 4. So option C will be your answer, minus 7 plus 3, that is minus 4. Question number 18, e raised to power x plus y is equal to 3x, then dy by dx. So we have to find out dy by dx, and if we check the options, so each option contains e raised to power x plus y, so we don't need to convert this using logarithm. So let us differentiate it directly. So e raised to power x plus y, differentiation of it will be e raised to power x plus y, and then using chain rule, differentiation of x plus y will be 1 plus y prime, and that is equal to differentiation of 3x will be 3. So 1 plus y prime will be equal to 3 by e to the power x plus y. So we can check from here, y prime will be equal to 3 minus e to the power x plus y over e to the power x plus y. So option D will be your answer. Now moving to the assertion and reason based questions. Question number 19. A line can have direction cosines 1, 1, 1. So we know the sum of the direction cosines. If L, M, N are direction cosines, so L square plus M square plus N square should be equal to 1. But if the direction cosines are 1, 1, 1, then this sum will not be 1. So this is not possible. So we can say that assertion is wrong. And the reason is cos theta is equal to 1 is possible for theta is equal to 0. So cos theta is equal to 1 is possible for theta is equal to 0. So this statement is correct, but this is not the correct explanation of the assertion. So we can say assertion is true, but the reason is not the, assertion is wrong, but reason is true. So assertion is false, but reason is true. So option D will be your answer in this case. Now moving to the question number 20. For two vectors A and B, mod of A cross B square plus A dot B square is equal to A square, mod of A square into mod of B square. So if we want to check the veracity of this statement, assertion, so this is the cross product, so we can say this will be equal to mod of A square, mod of B square and sine square theta plus A dot B square will be mod of A square, mod of B square, sine square theta. So if I take mod of A square, mod of B square common, so I will be getting, sorry, here it will be cos square theta because it is dot product. So if we take mod A square, mod B square common, so it will be sine square theta plus cos square theta, and that is equal to 1. So assertion is correct. Now reason is mod of A cross B is equal to mod A dot B tan theta. So let us check this. So mod of A cross B will be what? mod of A, mod of B, and it's a cross product, so sine theta, and directly it doesn't look correct, but if I divide it cos theta and multiply by cos theta, so we can say it will be mod of A, mod of B, tan theta times cos theta. So mod of A, mod of B, cos theta can be written as A dot B and tan theta. So region is also correct, but from this region we cannot say that assertion is true. So assertion and region both are correct, but the region is not the correct explanation of the assertion. So according to me, the option B should be your answer, that assertion and region are true, but region is not the correct explanation of the assertion A. So for 20th, option B should be your answer. So these were the 20 MCQs of 2026 CBSE Maths Board paper. I hope you would have done well. Thank you, and if you liked the explanations, please like and subscribe my channel.